Hello, today we are going to be studying ratios again. Ratios are comparisons between two quantities. Our essential question is, how can you demonstrate the relationship between two quantities? And this is from Big Ideas Math, pages 192 to 193 is where you can find the lesson. So if you have questions, you're always welcome to go back to your textbook that you keep at home, and you can review the lesson. These notes come directly from that lesson. We are going to start with the definition for a ratio. A ratio, and it's a comparison between two quantities. Ratios can be either part to part to whole, or whole to part comparisons. I underlined ratio because it is an important term, and remember, in order to get full credit on our notes, we need to make sure that we are using the revision process and that you are adding those marks that you've gone back and you've processed. So later on, when you go back through your notes, make sure that you highlight or underline important concepts and ideas, and you can add pictures, you can add notes on the side for whether this is a big idea for a test question or whatnot, but make sure that you add those in. As we go also, if you get done early while we're recording, we're writing down the notes, you can take a moment while you're waiting for the other kids to get caught up. You can take that moment to write a question and add that into the margin, because remember, in order to get full credit, you also have to have 3 questions and a summary at the end of the notes. So yesterday, or excuse me, not yesterday, the day before yesterday, we talked about ratios, and I gave you the example of my animals that I have at home, and I said I have 1 bunny, 1 tortoise, and I have 2 dogs. And I said that we would compare part to part would be like comparing the bunny to the dogs. I have 1 bunny to 2 dogs. Part to whole would be like comparing I have 2 dogs to 4 pets total. And whole to part would be like I have 4 pets total to 1 tortoise. Are you following along with me, guys?
Yes.
Okay, cool. So we're going to practice this. To do this, you each have 2 colors. It doesn't matter what 2 colors you have. I do want you to use 1 color, the same number that I do, in order for us to have the same ratios. It just will be different labels. So I'm going to start with my first color, and I'm going to draw 4 dashes, or 4 little backslashes. And then I'm going to take my second color, and I'm going to draw 2 backslashes. So I have 4 orange and 2 green. Now you might have 4 pink and 2 blue, 4 pencil, 2 pen. Whatever colors you have, you can label it your own, but I want you to do the same 4 to 2 ratio. Now, ratios can be written and I'm going to actually move my notes and make them a little bigger. So ratios can be written using ... words. If we're using words, we're going to say something like there are blank for every blank. Or we could use the word to. So, for example, you would say like 2 to 4. You put that 2 in there. We can also use a colon, and that would look like this. A colon is 2 dots like that, and you could have like 2 colon 4. Or you can have a fraction, which would look like 2 over 4. Now, fractions can be simplified, but never a mixed number. This is a sign for number. So you can make your fraction, if it's like 2/4, you could simplify it to 1/2, but if it was 4 over 2, you would never make it 2 because it has to be in a fraction form. So you don't want to ever change it out of that fraction form. Alright, so I'm going to make a little divider over here. Get that out of the way. Block out our definition. And we're going to do an example. So we're going to do examples showing how we write ratios. We're also going to do examples showing the different types of ratios using the data that we have. So using this data, we are going to first look at part to part. So for that, we would just compare the different parts within our data. So we have one part is the orange and one part is the green. So I would say in words, there are 4 orange for every 2 green. Now, I'm going to circle my numbers and underline the words that go with them. So there are 4 orange for every 2 green. Notice with this also, that's not the only part-to-part comparison you could do. You could have done there are 2 green to 4 orange. So you can flip them. It doesn't matter which one comes first. We can also write that with the other methods. So we could write there are 4 to 2. I could do there's 4:2, or I could do 4/2, which I could simplify, right?
No. Yeah.
I could. Now, I can't make it into a whole number. That's right, Xander. But could I instead make it, instead of 4/2, could I make it 2/1?
Yes.
It stays as a fraction, but it is simplified. Which that'll become useful later on when we do unit rates. Because unit rates are always out of per 1 unit. So, alright, so that's part to part. Let's try now part to whole. And I'm going to get a volunteer looking at my data up here. Can you give me a ratio comparing one part to the whole thing? Xander.
4 to 6.
So there are 4, use the frame please, okay?
There's 4 orange to 6 marks.
Correct. So there are 4 orange, that's one part, for every 6 marks. Could we have done there are 2 green for every 6 marks?
Yes.
Yeah, that would work too. Maddie, can you give me the other ways of saying it? So there's 3 other ways to say it, other than the words.
There's 2 to 6.
That's the other ratio, but what I'm looking at is more how we did this part, where we just rewrote the ratio in different ways of writing the same ratio, just different ways. So you see how I used the word 2, I used the colon, I used a fraction? Oh, I apologize, you're right. So you just did 4 to 6, correct? Is that what you're saying?
2 to 6 because that would be the ratio.
But we want to keep the ratio that we already had. I want it to all be the same. What's the other way? 4:6, and then 4/6. Can you simplify that?
Yes.
To what?
2/3.
2/3, right. And what you did is you just divided, I'm assuming, the 4 divided by 2, the 6 divided by 2, right? Cool. All right, let's do the last one, which is whole to part. Okay. Can somebody tell me what this one would be? Whole to part. Can I have another brave soul? Aiden.
Like 6 to 4.
So can you use the frame though? The words there are for every.
There are 6 for every 4.
Good. So there, I'm going to label it a little bit more, but there are 6 marks for every 4 orange. Now, remember, we could have compared 2. We could have done 2 green. It's really up to us, however we want to do it. And can somebody tell me the 3 other ways we can write those ratios? Jonah?
6 to 4.
Okay, 6 to 4. Good.
6:4.
6:4.
And 6/4.
6/4. Can I rewrite 6/4 simplified a little bit?
Yes. 3/2.
3/2. Good. I like that you didn't make it into 1 and 1/2. That was right, because you don't want to change it to a mixed number. You want to keep it in the fraction form, but you did simplify it, so cool. Now, guys, check this out. You don't always have to write your ratios in all 4 different ways. You don't have to write it with the words and using 2 and the colon and the fraction. That is overkill. I am just telling you what you can do so you can choose which way you want to do it, and you can do it that way. Now, if there's a question that I give you that says, write this ratio in 4 different ways or in 3 different ways, do you have to write it in 3 different ways then? Yes. And remember, those are the words with there are, for every, the word to, using a colon, using a fraction. But if I don't specify how I want you to write it, you get to choose which way you like to do it. And to me, it just depends on what I'm doing with the ratio. Very rarely do I write out the full words if I'm just doing it on my own. It's usually I'm just using a colon or the word to. Occasionally I'll use a fraction if I'm going to use it in a different manner. Okay, so what I'm going to do now is we're going to go over a page to 49. We're going to actually go back, and we're going to create a data table, and we're going to collect some data as a class so that we can use that data to find ratios. So I'm going to go to 49. At the top of page 49, we are going to write the question that we're going to address. What are the favorite ice cream toppings of our class? And we're going to compare data using ratios. Some people like saying data, some people say data, I say data. First step is we make a table to record data. Second, make ratios to compare. And also that helps us to find patterns. Alright, so now what I'm going to do is I'm going to create my data table. And I'm going to say toppings to students. And I'm going to give you a second to finish writing that down. While you're finishing that up, think about your favorite ice cream toppings. Don't talk to your friend about it, just think about it in your head. Finish writing those words down. And then I'm going to take some ideas. All right, do I have a volunteer who'd like to raise their hand and give me one ice cream topping that they prefer? Julia. M&M's. Those are good. Okay. Mackenzie.
Peanut butter.
Peanut butter. I like doing peanut butter. Olivia.
Peanut butter.
Okay. So Reese's peanut butter cup bites because of space. Carlos?
Peanuts.
Peanuts. Wow, you guys are a peanutty group. And for the sake of space, we're going to put other. And other represents the ones that don't fit in, that don't include peanuts. So out of these, in a moment, we're going to take a survey of the class and decide how many of you like each of those topics. The first thing I'm going to do is I'm going to count how many total students we have in the class today. 1. Okay, so we're going to write that we have 31 students total. So we should get our data to match 31. When you vote, I'm going to ask that you only vote one time and that you have to vote for one. If you don't see your favorite ice cream topping on the list, if you could, please just choose other. Or if you don't like ice cream toppings or you don't like ice cream, choose other. But you have to vote for one, okay? So if you like best M&Ms, raise your hand. Raise it tall, please. So I've got 1, 2, 3, 4, 5. Okay, let's write that down in our data table. If you prefer peanut butter, raise your hand. 1. It's okay. If you prefer Reese's Peanut Butter Cup Bites, raise your hand. So 1, 2. Okay? If you prefer peanuts, raise your hand. Okay? We have no peanuts. And if you prefer other, raise your hand. Okay.
I prefer chocolate.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We should have more than that, I believe. Yeah, so try again. Hold them up really high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, we're going to count him as 22. Is that right?
Let's put him in the nuts. Let's put him in the nuts area.
Alright, so we have 22. Let's see how we... 5 plus 1 is what, class?
6.
Plus 2?
8.
Plus 20. So we are missing one person didn't vote or didn't get counted.
Let's just give him nuts.
No, I didn't count him. Aiden, did you vote? Which one did you choose?
I voted peanuts.
You did what did you do?
I did other.
You did other? I don't think I counted you.
No, you didn't. You were right back.
Okay. Alright, so now we are good to go. Now that we have our data, let's start looking at ratios. The first ratio we're going to do is part to part. Can somebody give me a ratio using our data comparing two parts of our data? Yes. Yes, Tristan.
M&M's to peanut butter.
Alright, so we're going to say there are, Tristan, how many M&Ms? 5 students who prefer, by the way, I will not write everyone out this long. There are 5 students who prefer M&Ms for every, what was the other one you did? The longest one. There are 5 students who prefer M&Ms for every 2 students who prefer P or RPB bites. Okay. Alright. Can you give me another comparison of 2 parts? Another comparison, 2 parts. Maddie?
M&M's and other.
So, give me the ratio, please.
5 to 23.
5 M&Ms to 23 others. Good. Okay? Now let's try part to whole. Raise your hand. Xander?
There are 23 others for every 31 students.
Good. Okay? How about whole to part? Can you give me one for whole to part? Yes.
Other and
So you're comparing 2 parts. We want to compare, so what is the full amount? How many students do we have total?
31.
So 31 students to, you want to do others? Peanut butter. So we have 1 peanut butter. So we could also write 31 over 1, or this one would be 23 over 31. That would work as well. Alright, so now what I'd like to do is, now that we've done this, I want to show you one other thing that you can do with data. You could show your data in a tape diagram form. So if we wanted to compare M&Ms to, let's do peanut butter. Rather than writing out everything, you could do a tape diagram where you had five pieces, so there's 5 even pieces representing M&Ms. And we have 1 piece to represent peanut butter. So somebody asked me before, if you had none, what would you draw? Well, you would draw nothing. You would just label that there was nothing there. So that is another way to draw the diagram. Yes? Alright, so that is ratios in a nutshell. And I hope that you guys understand. We will be using this for the whole unit. It's kind of the foundation. If you have any questions, feel free to go back to the book and look at the lesson, or come in and talk to me or email me. Otherwise, make sure you begin your homework, add those questions and summaries, and have a fantastic day.